Hey guys, welcome to EIKV and this is so in this illustration the rate of return of the security of company A and market portfolio is 10 period are given. We have a table containing return of security A and return of the market and then period. The period we have 10 periods and the return of A would be 18, 20, 24, 26, 18, -5, 17, 19, -7 and 20. And return of the market would be 22, 20, 18, 16, 28, -6, 5, 6 and 11. Now you are required to compute the beta of the security A and what is the characteristic line of security A. So we need to compute the beta from here. So the formula for the beta would be covariance divided by standard deviation of a market square. So for the computation, therefore the computation of beta, we need to compute the beta, the standard deviation of security, market and covariance of the both. So for the computation of the standard deviation of the both security as well as market, have prepared a table. So a table containing the period and respective return, and then when we take the total and divided by 2 divided by 10, which is the total number of period, we will get that average return. So the sum total of the return would be 150 divided by 10, which gives you 15, and when it comes to market it would be 120, and 120 divided by 10, which gives you 12 as return. Now we need to compute x minus x bar. So x minus x bar would be a minus 15, and here it would be m minus 12. So 18 minus 50 will give you 3, and 18 minus 20 will give you 15 minus 20, 20 minus 15 will give you 5, and 24 minus 15 will give you 9 and so on. Then when it compared to the market return, it would be m minus 12, that is m would be 20, so 20 22. For first case it would be 22 and second case it would be 20. So the m minus 12 would be 22 minus 12 will give you 10, and 20 minus 12 will give you 8, and 18 minus 6, 18 minus 12 will give you 6 and so on. Now d1 and d2. So d1 it would be a x minus x bar the whole square, that is a minus 15 the whole square, which is 3 square 9, 5 square 25, 9 square 81, 11 square 121, 8 square 9, and 20 square it's 400 and so on. For d2, that is m minus 12 the whole square, it would be 10 square 100, 8 square 64, 6 square 36, and 4 square is 16 and so on. That we need to compute the covariance. So covariance is nothing but x minus x bar and a minus 15 multiplied by m minus 12, which is 3 into 10, which gives you 30, 5 into 8, which gives you 40, and 9 into 6 will give you 54 and so on. So after computing the m minus m or a minus 15 the whole square, which is d1, and m minus 12 the whole square, the total would be 1174 and 205. So when we divide it with 10, it would be 117.4 and 17.6. Over here, when it comes to the covariance, it would be 335, and which is divided by 10, it would be 33.5. After that, the standard deviation should be the root of 117.4. For security A it would be 10.84, and standard deviation of market would be root of 17.6, which is 8.4. Now the covariance would be of the market and security and the market would be 33.5. Therefore beta, the formula for the beta would be standard covariance of xy divided by standard deviation of n square. So covariance of x would be 33.5 divided by 17.6. the variance of the market. Therefore, the beta would be 0.4745. Now the computation of characteristic line. So characteristic line, the formula is equal to y is equal to Ra. Therefore, beta and x is equal to Rm. So y is equal to Ra, which is equal to 15, and beta would be 0.4745, and x, that is Rm, which is equal to 12. Therefore, y is equal to a plus bx. Y, which we have computed, that is the return of the security, would be 15, and x is equal to return of the market, which is 12. Therefore, 15 equals to a plus 0.74 into 12. So from that, solving that equation, we will get a as 9.32. Therefore, characteristic line of the security would be 9 plus 0.4745 Rm. So it is assumed that rate of return of market portfolio and the security given in the question are return in excess of risk-free return.